Hello everyone, welcome to my YouTube channel. Today I'm going to tell you how to Leetcode question number 3, longest substring without repeating characters. So given a string, find the length of longest substring without repeating characters. Let's look at example number 3, PWWKW. So the longest substring without repeating characters should be WKE or KW, which both have the length of 3. So the output should be 3. So obviously you can brute force it, but the time complexity will be too long. So there is a technique called sliding window technique, which will reduce the time complexity to O of n. So today I'm going to show you how the sliding window technique works. So let's see. So these are my code, and it's all already passed the test. Basically, we keep track of the maximum length of the substring when we initialize it to 0, and we initialize I and j to 0. I and j are the index, and we initialize it at the 0th position. And we create a set called current, and what it does is that it's the current substring without repeating characters. So and we are going to traverse the j. So the j will be first at index position 0, and then we are going to increment 1 by 1 by 1 by 1 by 1 until the last position of the string. And if the character at the position is not in the current set, we'll add it, add the character to the current string, and we'll update the maximum length, and we'll increase it by 1. Else we'll remove the we will remove the character at index position I, and we'll increment it by 1. So let's go through the code. So for PWWKEW, I and j are at the position 1, and the current set is an empty set. So there is nothing in here right now, for right now. And while j are less than the length of s. So if j is not in the current, so j is at index position 0, and its character is p, we'll add p to the current, and the maximum length should be the maximum of the current maximum length, which is 0, to j minus I plus 1. So j right now is 0, and I right now is 0, and plus 1. So our maximum length right now is 1, because 0 minus 0 plus 1 is 1. And then we'll increment j by 1. So j right now is no longer at position 0, it's at position 1, right? Then we'll go to the next one. So if sj is not in current, so right now our current is p and sj is w. It's not in the current, and we'll add it into the current set. So we'll add the W right here, and we'll update the maximum length. So our previous maximum length is 1. Right now it should be j minus I plus 1. J is 1 minus 0 plus 1. So it should be 2. And we update the maximum length. Now we go to the third loop. So if, and we increment the j to 1. So we increment the j to 1. Right now it's at the third position. If Sj, which is W, is not in current, so right now the Sj we have is actually W, which is in the current set. So we'll go to this one. So current, remove Sj. So in the current set, we'll remove the S at I. So we'll remove the P. And we'll increment the I by 1. So I is at position W. Position 1, which is the W. The maximum length, because we keep track of the maximum of the old maximum length and the current one, so the maximum length is not updated and it's still 2. Now we go on. Well, J, so if Sj, which is W, is not in current, again, it's in current. So we will go to this loop. Remove Si. So remove Si, which is the W. So we'll remove it, and we have an empty set of the current. And we increment I by 1. Then we go to the next one. If Sj, which is W,